The derivative of the natural exponential function is quite straightforward. d dx of e to the x is e to the x. What this means is the slope of the exponential function at any point is equal to the value of the function at that point. Now, d dx of e to the u is e to the u times du dx. So suppose I have the function and e to the 2x minus 1, and I want to take the derivative of that. Then it's e to the 2x minus 1 times the derivative with respect to x of 2x minus 1. And that is just 2, so this is 2 e to the 2x minus 1. Now let's look at this function right here. This one's a little bit more complicated, but the principle's the same. This is equal to e to the minus 3 divided by x times the derivative with respect to x of negative 3 over x. So this is e to the negative 3 over x times negative 3 times negative 1 times x to the minus 2. So this is 3e to the minus 3x divided by x squared. Now sometimes we're going to want to find extrema with our exponential functions. So if the function is x e to the x, then to find a local max or min, I find f prime of x, and I have to use the product rule. So this is x times the derivative with respect to x of e to the x plus e to the x times the derivative with respect to x of x. So this is just x e to the x plus e to the x times 1. So let me factor e to the x out. This is x plus 1. The only place f prime can equal 0, since this can never equal 0, is when x equals negative 1. Now I can use the first derivative test to see that this has to be a minimum, because when x is less than negative 1, then this is negative, and when this is greater than negative 1, this is going to be positive. Now the standard norm probability density function is something that's used quite a bit in the real world. So let's look to see where possible inflection points are, which means we need to find f prime of x to start with. So this is 1 over the square root of 2 pi times e to the negative x squared over 2 times the derivative with respect to x of negative x squared over 2. So the first derivative becomes, that's negative 2x over 2, so it's negative x divided by the square root of 2 pi e to the negative x squared over 2. For the second derivative, I'm going to need to use the product rule. So I'm just going to factor this 1 over the square root of 2 pi out. And I can probably factor this negative sign out as well. All right, so it's e to the negative x squared over 2 times the derivative with respect to x of x plus x times the derivative with respect to x of e to the negative x squared over 2. So it is 1 over the square root of 2 pi times, let's see, this first term is just e to the negative x squared over 2 plus x times the derivative of e to the x squared, e to the negative x squared over 2 is e to the negative x squared over 2 times minus 2 over 2, so minus 2x over 2. So each term has this e to the negative x squared over 2 term, so I'm going to factor that out. So it's e to the negative x squared over 2 divided by the square root of 2 pi times Did I lose my negative sign? I think I did. There's a negative sign out here. Times 1. Now what am I left with here? Minus x squared, because the 2's cancel. All right, so possible inflection points are when x is plus or minus 1. And lo and behold, that is what we see from our graph.